In this video, we're going to take a look at ellipses with an emphasis on how to write the equation when you're given the component parts. Now, the first thing you might notice about the shape of an ellipse is it's actually kind of like a circle that's just been stretched out farther in one direction or the other. But our formal definition of an ellipse is here at the top. It is the set of all points, so we're referring to the points all the way around the outside of this shape, whose distances from two fixed points, the ones here and here that we call the foci, have a constant sum. Now, when we say the distance has a constant sum, what we mean is that if I picked a point on the shape itself and then I measured the distance to one focus and the other focus and added them together, whatever the combined distance is will be the same no matter which points I pick. So then if I came down here and picked a different location, and again if I added up the sum to one focus and the other, the total of those two will be the same as the total of the first two. You shouldn't need to use that fact too much in working with the equations though. Let's instead look at the values that will be important for us. The first one is the variable a. It's helpful to think of this one as the long radius, basically whichever way the ellipse is stretched more, so in this case it's to the left and the right. A is the distance from the center to one of those endpoints. We usually call these endpoints the long way along the major axis endpoints. Sometimes they may be called the vertices instead, but it's the same thing. It's the long distance across the shape. It's like the long radius. B refers to the short radius. So the shorter distance across this shape, going from the center to the edge, we call those endpoints the minor axis endpoints. That will be the length of B. And then C is the distance from the center to one of those focus points. There are always two of them, so it doesn't matter which direction you go in that case. And that the focus points aren't actually on the ellipse itself either. So they're important for the definition of an ellipse since they create the shape of it, but they're not actually on the ellipse shape itself. A couple important facts to know about an ellipse: A and C will always go in the same direction. And by that I mean if the shape is stretched more to the left and the right, then both A and C will be measuring distances to the left or the right. And if the shape is stretched more up and down, then A and C will both be going up and down together. Another important fact when it comes to looking at the equation in a moment, since A is the long way across the shape, it might be going left and right, it might be going up and down, it depends on which way it's stretched more, A should always be bigger than B. A is, by definition, our longer distance from the center to the edge, and B is always the shorter distance. So A should always be bigger than B when you're looking at the formulas on the upcoming slides. So here are the standard equations for an ellipse. Again, we have two different versions, much like we did with parabolas, because there's the case where the shape is stretching more to the left and the right, and then there's the case where the shape is stretching more up and down. So other numbers that will hopefully seem familiar to you at this point, h and k, that's going to be the coordinate of the center of the ellipse. It's good to know that it will be the midpoint of the major axis endpoints, because the question may give you the coordinates for those two. Then you can find the center by finding the midpoint of them. Or it may give you the foci, in which case you can again find the midpoint of those two foci, and that would be the coordinate of the center. Or they may give you the minor axis endpoints, and again you can find the midpoint of those two coordinates, and that would be the coordinate for the center, the h and the k value. Those numbers go in the numerator of our fraction up here. K is always subtracted from y, and h is always subtracted from x, although the order that we write those in may change. Another term you may see on some questions is a major axis length. Well, the major axis endpoints are the ones across the long way around the shape. So the major axis length is kind of like the diameter. It goes all the way from one endpoint to the other, while as A is just like the radius. It goes from the center to one of those endpoints. So if you're ever given the major axis length, you'll usually want to divide it by 2 so that you know what A is. The same can be said for the minor axis length. That's the short diameter across the shape. So again, if they give you the minor axis length, divide it by 2. Because B is just the distance from the center to one of those endpoints. Some questions may give you some of the information dealing with the one of the focus coordinates, for example. So maybe you can find C. So what will often happen is you might know 2 of the values out of the A, B, and C lengths. And if you know 2 of them and you need to find the third, you can use this formula right here, a squared minus b squared equals c squared, to find whichever number you're missing. Now you'll notice C does not actually appear in either of the equations. But like I said, the question may give you information to find C, and then they may have also given you B. So in that case, you would have to solve for the one you do need in the equation, the a value. Here I have some general tips and reminders based on the information you're given in the upcoming examples. So we talked about some of these already. If you're given any pair of points like the major axis endpoints, start by finding the center by using the midpoint formula. And I've written that midpoint formula out here for reference if you needed that. Another thing you can do if you were given a pair of points is you can find the length from the center to one of those points. So maybe they gave you a major axis endpoint, then find the distance from the center to that coordinate. That will be the length of A. Maybe they gave you a minor axis endpoint instead. Again, you want to find the distance from the center to that endpoint, and that will be the length of B. If they give you a focus, or maybe they give you both of the foci, then again, find the distance from the center to that point, and then that will be your length of C instead. Something to help you identify which of the equations you should be using is paying attention to whether it's the x coordinates or the y coordinates changing in the information you were provided. For example, if they give you the major axis endpoints, then that means that's the long distance across the shape. If it's the x coordinates changing on them, then we're going to put A underneath x. Or vice versa. If it was the y coordinates that were changing, that were different between the two major axis endpoints, then you're going to put A underneath y instead. And we mentioned this on the last slide, but if they give you an axis length, either the major axis length or the minor axis length, make sure you remember to divide it by 2. That's what your A or B value will be based on whether it was a major axis or minor axis endpoints or length. Now we'll start looking at some examples, and again, just like with the parabolas, I do highly recommend drawing at least a rough sketch of the shapes, and that might make it easier to identify the equation and any of the missing parts that you need. So this one gave us the major axis endpoints, so I need to plot the point 0, -3, which means go down 3 and draw a dot, and 0, +3, which means go up 3 and draw a dot. Now, they also mentioned that we have a minor axis length of 4. So remember, that's 2 times b. So that means I know that the short way across the shape, the short radius, is 2. So the long way appears to be 3. The short distance in the opposite direction is going to be 2. So this is very similar to drawing a circle. I'm just going to connect those dots around the outside of the shape here, and I'm expecting it to be kind of stretched out more in one direction or the other. So it doesn't have to be perfect, but this is helpful for figuring out the equation. Now, on the previous slide, I mentioned as a hint that whenever you were given a pair of coordinates, the first thing you may want to do is find the midpoint of those points, and that will be the location of the center. So you can do that algebraically. You also might be able to just look at this shape and see that the midpoint between everything had to have been at 0, 0 in this case. The other numbers we need to find are the A and the B values. Now, A is the long radius across the shape, so if you have your graph drawn, you can see that that distance is 3. And B, we actually talked about earlier. Since they gave me the minor axis length, I divided that number by 2 to get to, but also I can see that on the shape as well. If I went 2 the short way across the shape, that's my B value. So now we just need to put this information together and pick the correct equation for writing it out. Now remember, A is always bigger than B, so when I'm looking at these two cases, we know that this shape is stretching more up and down, so I'm going to have the bigger number underneath Y. If it had been stretching more to the left and the right, then I would have put the bigger number underneath X. But for this example, I'm going to be using the formula here on the right. So just from plugging into that formula, we would have y minus k squared over a squared plus x minus h squared over b squared equals 1. But then to simplify this a little bit, we don't need to write the minus 0, so I just have y squared. And it's important to calculate it out. 3 squared would be 9. Same thing with the x's. We don't need to write the minus 0 squared, so just x squared. And 2 squared equals 4. So that's the first equation for standard form of an ellipse. Okay, so now let's look at a second example. This time we were given the minor axis endpoints, and they gave me the coordinate 2, -1, and 8, -1. Then they told me that the minor axis length is 10. So remember, I can divide that number by 2, and that will give me the value for A. So A is going to be half of the axis length, so 5 in this case. Since we also have this pair of coordinates, we can find the midpoint using the midpoint formula, or you might be able to just see this from looking at your sketch and saying how many points over is it going to be. That would be exactly in the middle of those two. So you can use the formula to do it algebraically, or graphically it's pretty easy to just measure what would be in the middle. Well, if the minor axis endpoints were going left and right, then the major axis endpoints will be going up and down. It'll always go in opposite directions in this case. So from my center, now I know to measure up and down 5. And then that would be the rough shape of my ellipse here. I can also measure the distance from the center to either of those minor axis endpoints, and I can see that that length is 3. So now I know that the b value is 3, the distance from the center to a minor axis endpoint. And I can see the coordinate for the center. So my h and my k value, that we'll need to plug into the formula in a moment, it's 5 and -1 for the center. So this can be done with formulas. You can do a more algebraic approach, but graphing makes it a lot easier in my opinion. So now pay attention again to which way this shape is stretching more, because remember we want the bigger number, the a value, to go underneath either x if it's going more left and right, or underneath y if it's going up and down more. This one has the b values going left and right, so then I'm going to have a, which is going in the y direction, underneath y in this case. So here are the formulas. Again, we're using the same one that we did on the last example. I want the bigger number underneath y because this shape is stretching more in the y directions. I've gone ahead and already simplified it. Don't forget that you are subtracting the numbers so the signs flip. So you end up with y plus 1 squared. Don't forget to square the a value, so 25, and then x minus 5, and then I squared the b value to get 9. This side of the equation is always equals 1, so that part's easy. Okay, one more example. We have an ellipse with the major axis endpoints at 6, 0, and -6, 0. So again, we might want to find the center as soon as we're given a pair of coordinates. The point that would be exactly in between these would be the point 0, 0. And since I now know the distance from the center to one of those coordinates, doesn't matter which direction I use, then now I know, since those were major axis endpoints, that A is 6. Now the other piece of information they gave me was the foci. Now remember, the foci and the major axis endpoints always go in the same directions. These are not the minor axis endpoints, so do not go in the opposite direction for this. So they gave me the foci of 5, 0 and -5, 0. So right now I don't actually have enough information to figure out the shape of the ellipse because I don't know how far to go up and down from the center. But I do know that the distance from the center to the focus was 5, so that means we know the c value. So this is where we're going to come back to the formula I gave you here. We know 2 of the 3 values. In this case we know a and c, but we need to find b because b is a part of the equation and we don't know it yet. So we're going to plug in the 2 numbers we know and solve for the one we don't. So here you can see I've plugged in a squared minus b squared equals c squared. I then subtracted 36 from both sides of the equation to get -11, and then I multiplied both sides of the equation by -1 to get +11. Now we don't actually need to solve for b. It's okay to leave it as b squared because that's actually what we use in the formula. We don't solve for b, we solve for b squared for the denominator. So our last step is to pick the correct form of the equation we need to use and then to just plug the numbers in. Now notice that this shape is stretching more to the left than the right. So on this one, we're going to have the a value going in the x directions. So this time we're using the formula on the left. The only real difference here is that the x minus h and the y minus k parts have flipped. We're going to leave everything else in the same order. So since we had the center at 0, 0, that means again we had the situation where there's just an x squared and a y squared on the numerator. Don't forget to square a to get 36 in the denominator. But then this one is b squared, so I don't need to square that number again. We wanted b squared, so my denominator was 11, and we want to make sure that we always have the bigger number. That one should always be the a value. If I had squared this, I would have gotten 121, so then it would have looked weird that I had a bigger number going in the y direction instead of in the x direction. So that's it for writing the equation of an ellipse and also kind of sketching the graphs at the same time. I hope that was helpful.